Hello, hi. My name is John Kaipoff, and I am really excited to share this data visualization that I've been currently working on. For the longest time, a lot of people ask, hey, John, what do you do? And I've always had a hard time explaining that to other people. So I used to say, well, I make things with computers and glue, but people don't quite understand that because like a lot of you, I like to play music, I write code, I love design, I have an entire digital fabrication shop. I work with electronics, I'm into film, I own a business, and I'm also an educator. So I teach creative coding, electronics, digital fabrication, product design, digital media, and data visualization in the interactive multimedia department at the College of New Jersey. And because it's the Empire State Maker Faire, I also teach digital fabrication at the ITP program at NYU. So one of the things that I love about data visualization is that it's an opportunity for me to take all the things that I love and you can put them all together, right? And so what I'm doing in this presentation is showing you how you can use code and all these things to build something that you can literally hold in the palm of your hand. So let me show you really quickly the finished product. Literally the glue is still drying. The technology is working. It hasn't fallen over. So I'm really excited to show you at least the final product, and then we'll talk about how I got there. So what is going on there? So let me try to explain this a little bit. So we're going to talk about the prototypes in just a second, but this is the first prototype. And this was developed using Python code, right? And so the way this actually works, it's a clock. I'm going to go to my shop cam real quick so you can see what it looks like. And so each ring is an hour. So the very top ring, that's midnight. And the bottom ring, that's 11 o'clock p.m. And you'll notice that there's a light sort of a little bit more than midway down, which means it's 4 o'clock, or about 4:30. And so what this data visualization shows is how much sun radiation, and if I'm looking at this right here, how much sun radiation, and this is October at 4 o'clock, how much sun radiation is shining on this at my exact location in my garage at this exact time. So you'll understand what I mean in a minute. So my garage, check this out, this is pretty cool. I live in on a suburban street. And so right now the sun's shining over my garage. There's a certain amount of sun radiation that happens at this time of the day. So that's my workspace. And so this data visualization can show that. So let me show you how that might work. So all of this started with a line of code. So a lot like many of you, I'm naturally curious and I like to tinker with things. And instead of watching Netflix, oftentimes I have a much better time just sort of playing with code. And so I stumbled across this library called PySolar. Let me bring this here. Hopefully you can see this. Cool. So this PySolar library, I saw that if you put in just a little bit of code, it tells you how much solar radiation happens in a given area, which I thought, well, that's really neat. So I installed the library and I'll run it for you. So here's the code, right? Just that little bit of code there. And if I open up terminal and I run that line of code, it gives me a number. So 30.91. That's kind of cool. But what if I change one of the numbers? What if I make this number like an 8? I'll save it. And maybe let's try playing this again. It's a different number. Well, that's kind of cool. So what can you actually do with that? And so that is where like the whole journey began, right? So it's like, we have these numbers, but what does all that mean? And so I think the website actually has some kind of data visualization, but it doesn't look like that. It's not something you can hold in your hand. So I played with it a little bit. I went back into in brackets and I started playing with the data. And I said, well, maybe I can get all of all the solar radiation data for every hour of the entire year for a given location. And then once I had all that data, it's just a ton of numbers. What are you going to do with that? So then I brought it in and I wrote some JavaScript to start turning these things into shapes. And once I did all of that, then I decided, well, you know what? Maybe I can make an app that can do it for any location. So I'm going to put in, my hometown, because that's where I am, Stockton, New Jersey. And I'm going to build that map. So we found something there, and I can hit build. And it takes a little while to run because it's doing a whole lot of math, but in about 10 seconds, it'll start building each model. So it's using Python, it's using JavaScript, and a bunch of backend software to run this. And essentially what it's doing, it's writing SVG files to, that you can download when it's all done. So now we're starting to get some real kinds of shapes. And this was a very exciting thing to be able to see something like this. So we'll let it run its course, because you're going to see something similar to this a little bit later when we get further in the presentation. Almost there. And when you're done, you can download that zip. And that's basically going to give you a lot of different shapes that you can bring into Illustrator, and you can cut them out. So the inspiration behind this project, one of the things I love to do, and I don't do it a whole lot, but I love to travel. And I love it. So like when you travel, you get off the airplane and you're on you get out to the world, and the sun feels different depending on where you are. So if you're in Florida, the sun just feels different on your skin than if you're in California or New Jersey or in Spain or wherever else, right? So I'm fortunate to live in a really, really beautiful area right along the Delaware River. And I fly my drone a lot, and a lot of times like to get like scenic views. And so some of this drone footage was the inspiration behind this project. Let me show you where I live, and then we'll get into some of the code. So it's a small town. It's called Stockton, New Jersey. And it's got this bridge that you walk across. And every morning and every night, it's just like a really nice walk. And that's my town. The small town, there's a little farmer's market, and used to be an old railroad, and a lot of farming still. New Jersey still has farms. And there's also a lot of history, a lot of events, and a lot of artists work here. And, I always have the saying that I wish I could capture the sun like in a bottle, especially as it's getting a little bit colder out and things like that. And I wanted to just sort of keep that right in a model. So I got all the shapes, I wrote the software, I downloaded all the shapes, but now you want to see what it looks like, because it's one thing to see it on the screen. And so what I decided to do, I own a Glowforge. It's one of my favorite tools. It's a prototyping tool that I use for pretty much everything. It's quicker than a 3D printer. And so what I did is I took those initial designs and I brought them to my Glowforge, and I tried cutting out the shapes to see what they look like. So let me show you a quick clip of me doing that. In fact, I just upgraded to the Pro, so I got the Pro coming in on Tuesday. So this is my basic. So the laser, it can pretty much grave or cut anything. And then you got to start putting these models together. So I just got like a little skewer, and you just glue it. You just glue it all together. And in the end, you get to see what it looks like, which is extremely satisfying, as you'll see. I don't really work this fast. It's like my Jimmy DeResta speed up. You guys like to pick on the table. And also, I'm happy to answer any questions as they come in. Feel free to put them in the chat. Yeah, my workshop isn't always as clean. It's usually just where the camera's pointing. Right now, my workshop looks more like it's lived in. Yeah, actually, it's still not bad though. It's not bad. I got everything tucked away in the closet. That's basically how it works. So this first model, check this out. So this first model was really satisfying. So this is right my garage is, right? But what about other places? So since this is the Empire State Maker Faire, I also made one for New York. Now, the two look very similar, right? There's not that much difference, but there are slight differences, which to me is the most fascinating thing in the world. So yeah, New Jersey, New York, at least when you compare the sun radiation, they're basically the same place. But what happens if you move a little further away? Like, so let's just say if we go to Siberia, Russia, what does that look like? So Siberia, Russia is a much smaller model than some of the others. And you can see that like basically in the summertime, it's light out quite a bit, but in the wintertime, it's like, it's literally almost completely dark. So that was pretty interesting. That's way up north, right? I also have, these are all places I haven't gone to. This is Rome, Italy. So Rome, Italy looks a little bit like New York, but if you have them side by side, they look different, right? So then I got curious. So of course you're going to want to test the extremes. Like the first thing you want to do is like check out your backyard. But then what about something that's like maybe like one of the brightest places on the planet? Where is there the most sun radiation, and what does that look like? And being dramatic here, I'm going to pretend it's heavy. So this is Ecuador, and so Ecuador, it's huge. It's when it's sunny, it's like crazy sunny, like basically all the time. And then when it's dark out, it's dark out. One of the other things too, because I know somebody's going to ask, you're going to notice that Ecuador has these nice round shapes. But when we looked at New York, it was it has like all kinds of spines and things on it. It's like, what's that about? Well, I mentioned I was doing all this rapid prototyping on the Glowforge, and my first models, everything started to look like this. And when I decided I was going to make it a clock as well, something didn't quite add up. So the importance of rapid prototyping is again, like testing your data. And I realized, well, Ecuador doesn't have daylight saving time, but New York does. And so what I had to do is write a little bit more code to compensate for daylight savings time. So that dip right there, that's the morning like that we set our clocks back, and essentially like it's dark out. And we're like, oh, I can't believe it's dark out already. So like you can actually see that in the data, which is pretty cool. But moving on, so another extreme from New Jersey is Australia. So Australia is literally like the opposite of, because it's in the Southern Hemisphere, of New Jersey. So it has similar looking shapes, but everything's inverted, right? That's crazy. Another one I just wanted to check because of the pyramids, right? Is Egypt. Egypt has a lot of sun. And then of course you got to try the biggest extreme, which is, if anybody could guess in the chat, although I think there's a slight delay. So I don't know if people are guessing. Let's grab this one. Anyone want to guess what this one is? I literally just glued this one together this afternoon, so it's still fragile. Oh, so I just showed it. North Pole. Now North Pole would look like this. This is Antarctica. This is the it's one of the stations. So if you do like South Pole, and I did that, and I think I lost that model. It's somewhere out of reach. Mathematically, it's like perfect, but still not a very interesting shape. So this is the South. This is basically the South Pole, where basically, during all these months, it says the summer months. So I think hopefully I put this on right. In the summer months, it's like completely cold, completely dark. And you can see the shape here, like in the other months, it's like daylight 24 hours. So like, I always knew this in the back of my head, but be able to see this and hold it in your hands, like that's a different thing, right? You can't show that in a chart in the same way you can show it in a visualization like this. So the class I teach at NYU is called Making Data Tangible. And essentially that's the premise of the class. We go out, we collect data, And we record data. Sometimes it's through code, sometimes it's through, just observation, because all the folks in the class, they come from all different walks of life and all different skill sets. So it's really easy to be able to collect data, even if you're just observing things. And then you put it in a data visualization in the best way you know how. So if you're a musician, you can create data visualizations that are songs. Or if you're like a quilter, you can make data visualizations that are in the form of quilts, or pretty much, all kinds of different ways. So I love data visualization because in a way, it makes things like coding more accessible and design more accessible and things more accessible. It's a way to bring people together. So yeah, I really love data visualizations. So anyhow, I got these prototypes done, which was pretty cool. But they're just prototypes, and they're cool in their own right. And so I decided I wanted to make the one that I showed you before, which is this guy. And so I want to talk through that process a little bit, because this was harder than I thought. And it's funny. I messed up a lot, but I still love the process, and I wish it didn't take till like an hour before this presentation to sort of finish it. It's hot glued together, but there we are. So the first thing I had to do was make the discs. So let me show you my overhead cam. I started making these discs like this, and I had a couple different prototypes here. This one I didn't stand. This was an extra one because I thought I was going to break it on the CNC. And to get even this far, I had to try lots of different kinds of acrylic, different kinds of glues. I broke some drill bits because things were binding up. I tried all different thicknesses and things like that. But ultimately, at the end of the day, let me show you how I made them. This is Willard Brothers, my favorite store in the whole world. You can buy any kind of lumber there. So here I'm resawing the wood because you got to make it thinner. And then here, we're going to make an acrylic sandwich. So we're just using CA glue here, and then 16th inch acrylic. So I own a ShopBot Desktop Max. Love the machine. It loves me back. And here we're going to cut out all the discs. And so now that I had all the pieces, first thing I want to do is see how they all went together. And then you roll them out. And you got to number them, because once you take them off the CNC machine, you really can't, you don't know which time is which, and that's important. So you write them all down. And then the next part, I started filming, but it was such a mess that I got frustrated and I stopped filming. So I had this idea where I could 3D print this jig, because I needed everything to line up. So the idea was I would put these pieces on here, and then I put some glue on that piece, and then slide one in, and then put glue on that piece and slide another one in, and then put glue on that piece and slide another one in. And that worked great, right? Everything was perfectly lined up. And, I did tests to make sure that glue didn't stick to PLA, right? Because when you're making things, I probably spend more time testing things than actually making things. So I did my tests and I clamped it, and I woke up in the morning, I peeled it apart, and everything was great. So I had this all together and I glued it all up. I had to do it in 2 halves. And the first half, it didn't budge. And so I didn't know what to do. So I'm pulling at it and this and that, and it's not working and like it's not budging. So then I'm like, I take a hammer and like this other pole and I'm hitting it and down into the breaking the thing apart, and the pieces are like literally flying all through the shop and everything's breaking, and I'm practically crying because this is like, you know, so it didn't work out, but that's okay, because a lot of times when that happens, you know, you just come back the following morning and you try it again. So I got all the pieces, I cleaned everything up, resanded it, and just sort of glued it by eye, and was more careful and used like paint cans and weird things to prop it up. And that seemed to work pretty well. And then I did the other half the same way. And then my friend Brett, who's on this call, watched me try to assemble the whole thing. So that part was good. The next part that I wanted to do, because I had already done the coding, I'd done the design work, I had done like the fabrication, but now I want to do the electronics part of it. And so I wanted it to make it a clock. So let me talk you through that a little bit. And it's actually pretty simple. It's pretty simple electronics. So I was using a timing circuit, essentially, where it keeps time, and an Arduino microcontroller. And the code is basically just mostly taken off of the example code. And essentially, every time the hour switches, the lights move up. And so that's what you're seeing there. So depending on what time it is, that ring is the one that's glowing, which is pretty cool. It's a clock, right? And a lamp and a data visualization and all those things. So that was pretty simple, but even getting that and the tube with hot glue, make sure things didn't short circuit. So there's a lot of planning and prototyping that happens in there. And then finally, I wanted to make the base, and I'm going to go back to the shop cam, and I'm going to have to tilt the camera down so you can see it better. So just give me a moment. I'll be there in a second. So I'm back. So what I want to do for that, you probably noticed I'm actually using a piece of redwood burl that was salvaged from a forest fire, which, because it's the sun, I'm doing a solar, it makes sense that it came from fire, and that this wood looks like fire. And I wanted the base to look like the sun, right? That was the basic idea. I wanted the base to look like the sun. And then I wanted, I was either thinking brass or stainless steel to put as the base, where you could laser mark the months on there for the base. I asked Instagram, and Instagram was saying, we like the brass, although I still like the stainless steel. I might try stainless steel as well. So yeah, so that's the project. And it's one of many visualizations that I've made. And I'm, you know, I love doing this stuff. And if you're an educator, I think that data visualization is one of the easiest and most accessible ways to teach a whole lot of different, you know, disciplines and concepts. And they're fun because you can approach it at any level. So I'm going to see if there are any questions. I'm going to wrap this up, and thank you. So does anybody have any questions? Anything you want to talk about? Okay, cool, good. Questions are coming in. So the question is, what is one of the hardest concepts to visualize that you have come across? Well, the thing about data visualization, it's, in many ways, data visualization is a form of storytelling. And sometimes you collect all of this data and you spend all this time mining data, and whether you're doing like page scraping, you're working on API calls, you're doing like direct observation, you're recording it all, and you finally put it all together. And sometimes the story's just not that interesting. And that's like the most disappointing thing. So even in my classes, like they'll spend all this time collecting it, and then when you see the data, it's like, there's not really a story there. And you can't fabricate a story because that's, you just can't do that. You have to visualize it like, you know, truthfully. But one of the hardest concepts to visualize that you've come across. Every project has its own, I don't know, its own difficulty. So one of the more recent ones I did was the emerald ash borer. We have these, at least on the East Coast, we have these, essentially these bugs that are killing all the ash trees. So trying to visualize like how many trees are actually killing I did a project like that, and figuring out, once you get that number, like how do you visualize that number? How do you make that number something that people can relate to in a meaningful way? Because there's one thing to just state some kind of statistic, but it's another thing to show it in a way that people understand it. So I think that's the hardest thing. So what I love about these data visualizations that I built here is that you can instantly see, like in 1 second, from all this data, you can see the difference between summer and winter, and actually see like the nuances between all the different seasons. Okay, next question. You are using so many methods. What tools are your favorites to use? I love my Glowforge. I have a laser cutting video that it's on YouTube. You should check it out if you're not subscribed. I'm guessing most of you aren't. So like the laser cutter, and these are Maker Faire things. So the laser cutter can cut and etch into a variety of materials. So we got leather. I should have been naming these. That's cork fabric. That's paper. That's wood. That's slate. We have metal. So the laser cutter is probably my favorite because it's so versatile. After that, I just love the CNC machine because you can make really beautiful things with it. But honestly, it's just code. I love coding because code, once you learn how to talk to a computer, it's like any other piece of software where you can just use it to get the information that you want, and be able to write your own software. The fact that I could write my own software that other people could use to generate their own solar visualizations, like that's an empowering thing. And yours don't have to be out of wood. You can get the shapes and cut them out of fabric, or cut them out of acrylic to make jewelry or something like that. So code and digital fabrication tools are my favorite, really. And honestly, just some time to think and to like have an afternoon. I think time is the most important tool. Setting aside time to sort of just muse and tinker and experiment with things, even if the experiments don't always go somewhere. So cool. Love that. Next question. I love that you admit that things didn't always work. What are some of your favorite mistakes? I don't have any favorite mistakes. Mistakes are painful. They're almost all very painful. But if you didn't have the mistakes, then when things worked out, and which they normally do, by the way, it wouldn't feel so good. Like pride comes, I think, in part from working through your mistakes, right? If everything just worked perfectly all the time, you wouldn't be proud of anything you're doing. If you're not proud of what you're doing, then you don't have the motivation. If you have the motivation, then you're just going to watch Netflix all night, which is cool, which is fun. But making things, it's, there's a saying, and I'm going to screw it up, but that a mistake is basically just an experiment. I'm going to mess this one up. Yeah, basically you learn from every mistake, and it's just an experiment where the results didn't quite pan out the way you had hoped. Okay. Any other questions? Okay, data can be used wrong. Have you seen examples of bad data? Absolutely. So in one of my classes, in my data visualization class, a lot of times we'll see, like, for instance, things that I'm thinking of a ton of different examples in my head, but it's not that always the data is bad. And sometimes the data is bad, but oftentimes it's represented incorrectly. Like, for instance, if you have two bar graphs and they're both not on at the same plane, so it looks like one's a lot larger than the other. So there's ways that it's represented that's wrong. Yeah, there's a lot of bad data out there, and when people have an agenda for some reason, you want the data to work in your favor, and there's ways to manipulate it where it appears that way. But part of having I guess data literacy is to be able to see through that. And so the classes that I teach at TCNJ and NYU, I like to think students learn some of that, at least know where to look. Great. All right. So if anybody here is into data visualization, I think the best place to start, honestly, is a lot of people, it's well, how do I get into that, right? Is just observation. So if you look at the world differently and start observing the world and recording it, and recording that data in some format, you'll often start to see patterns. And it's really interesting to see what mediums you can use to basically tease out those patterns and share them with people. And so if you have kids, you can look around your house and make data visualizations of all kinds of things. For instance, how long is everybody on the phone in the house? Can you record that and visualize that in some meaningful way? Like maybe put it in a metaphor or a song or a drawing, or maybe using Legos or something like that. Another question, what are some other projects or ideas you are trying? I am trying lots and lots of projects because I have so many different hobbies, and I like to mix them all together. I think the next thing I'm going to try to do is I'm going to make, it's actually a desk. And this desk is going to be, I guess, how do I explain this? The desk is going to be the ultimate desk and it's got a lot of gears in it. So that's the theme. The theme is gears. So it's very mechanical, and it's going to have all these different tabletops. And so it's a lot of experimenting with materials, with water jet cutting. Some of this is going to be written using code, like the shapes and the geometry and patterns from nature. And so it's every project that I have is usually a culmination of a lot of experimentation. And for me, it's the process that's the most important thing. To be honest, you know, like the lamp itself is cool, but it's just a lamp. What I love the most is all the process that helped get you there, all the experimentations and all the lessons learned along the way. And it's nice to share it when you're all done, because after this, nobody's probably ever going to see that lamp. It's going to sit on my desk that I'm building. Yeah. So. So what is your background? What did you study? So a quick, so my background, originally I was going to go in for, I was going to study music. And I went to college in the year 2000. So we didn't do a lot of research. So I got to the college, or I was thinking about college, and I learned that if you're a music major, you have to play other people's music. You can't play your own music. And I was writing a lot of songs at that time, but at the same time, Photoshop was pretty new and I was learning that on the side. So I thought maybe I can do graphic design. And they needed this thing called a portfolio, which I didn't even know what that was. But I made a portfolio in a couple of weeks, and somehow that got in, and I went into art and graphic design. And I loved being able to, for instance, like doing branding work, where you take all the ideas behind a company and you condense it down into its like simplest shape, right? So after graphic design, I was doing a little bit of that. The web came out and I started designing for the web. And then the coding seemed more interesting than the design. So I spent 12 years writing code and apps and educational apps and things like that. After some really tough freelance projects, I decided I need to get away from the computer, right? Got some woodworking equipment and never looked back, sort of. For a while, for a couple of years, all I did was woodworking. Eventually, computers found their way back in, got into digital fabrication. I learned everything from YouTube. So then I bought a bunch of camera equipment, and I'm currently starting a YouTube channel. And eventually I'd like to start making products and start my own school someday. So I'm always bouncing around like all the time, right? And I realize if anybody in the audience is wondering like what they should do with their life, that's something I hear students talk a little bit about. It's really good to figure out patterns in all the things you like. So I've realized that I like taking little things and putting them together to make bigger things. So if you're doing coding, you're taking little lines of code and you're building it to make a game, or you're building software. If you're building something with digital fabrication tools, you have like these basic ingredients like wood and acrylic and plastic and shapes and this, and you put them all together and you have something like that lamp that I just made. If you like, I love to cook, simple ingredients, you put all together and you have a dish. So I can pretty much any career that involves me taking small little things to make something bigger. For me, that's the reason I want to wake up in the morning and get to work. So finding those patterns is more important than what you do. It's just figuring out the kinds of activities that you like. All right. Anything else before we wrap things up? The sun's beating in on me. It makes sense. Like right now, the sun it's a solar visualization. It's like I could feel that solar radiation on me. All right. It seems like there aren't any other questions in the meantime. I'll wait just another minute or so. Do I have any sites that I want to share? Please follow me on Instagram. If you want to see more data visualizations and more experiments, please follow me there. But as far as sites, I think it's important if you're, no matter what you're doing, whether you're doing data visualization or film or music or design, you need to find heroes in your life, and they might be online, and maybe they're people you've already heard on in Maker Faire. But go follow them and view their sites, because you need somebody to look up to as you're going through a journey of becoming a musician or becoming a data analyst or whatever. Find those heroes and the spaces that they're working in, and you know, aspire not to be them, but to be sort of like them in some ways. So I think it's probably my best advice. I watch a lot of YouTube. I think everybody watches a lot of YouTube nowadays. It's everything in the shop that I built. I learned from YouTube, right? And also any site that has some really cool data visualizations, colossal.com. That's one site that's pretty neat. Any other questions? All right. So I'm going to ask the moderator, should we wrap this up now, or? All right, great. Well, thank you very much. I appreciate you tuning in, and hopefully I'll see you on YouTube or Instagram. Look forward to seeing the rest of the presentations. Take care.